If the sun's so hot, why space freezing? The sun is no joke. Its surface, called the photosphere, is around 10,000 degrees Fahrenheit. That's hotter than anything we've ever seen on Earth. And at the core, we're talking millions of degrees. So yeah, the sun is blasting out insane amounts of energy every second. On Earth, when you feel warm, it's usually because air carries that heat. Molecules bump into each other, passing energy along until it reaches your skin. Think about opening an oven door. It's the wave of hot air that makes you jump back. But in space, there's no air, no molecules, nothing to transfer heat that way. That's the first big clue. Heat transfer crash course. Heat moves in three ways: conduction, convection, and radiation. Conduction is touching something hot, like a pan. Convection is hot air or water moving around, like boiling water or a heater. Radiation is light energy traveling through space, like sunlight on your skin. In space, only radiation works. No air for convection, no solid stuff for conduction. Just light energy flying through emptiness. Those photons, little packets of light, leave the sun and travel 93 million miles until they smack into Earth, your skin, or a spaceship. They don't need air or anything else. That's why we can still feel sunlight even though space in between is a vacuum. If you're in space and sunlight hits you directly, you'll heat up. Astronaut suits can reach 250 degrees Fahrenheit in sunlight. But step into the shade behind a spacecraft, you drop to minus 250 degrees F. That's a 500-degree difference just by moving a few feet. With no air to spread the heat around, it's all or nothing. The moon shows this perfectly. In daytime, its surface is about 260 degrees F. At night, it drops to minus 280 degrees F. No air, no atmosphere, just brutal swings. That's why astronauts wear those thick white suits. They're like personal climate control machines. Earth doesn't act like that because of our atmosphere. The air holds heat, moves it around with wind, and traps some of it. That's why our planet feels way more balanced compared to space. Space is extreme, Earth is cozy. Think about a thermos. It keeps soup hot by using a vacuum seal. No air inside, so no conduction or convection. The only way heat escapes is radiation. Space is like a giant thermos, except instead of soup, you've got planets, spaceships, and astronauts floating inside. Some people think space is cold because it sucks heat out of you. Nope, space doesn't suck anything. What really happens is your body just radiates heat away. Without air or insulation, you lose energy fast. That's why astronauts need those high-tech suits to stop them from freezing on one side and burning on the other. So, the big picture? The sun is insanely hot, but space feels cold because there's nothing there to hold and spread that heat. You only warm up if sunlight is directly hitting you. Otherwise, you're in the deep freeze. Crazy, right? Next time you feel the sun on your face, remember, you're catching photons that left the sun 8 minutes ago, traveled 93 million miles through empty space, and landed right on you. If that blew your mind, hit like, subscribe, and drop your wildest space questions in the comments. I might tackle yours in the next video.